Hello everyone and welcome back to the Proactive Learning YouTube channel. Today we're going to go through question 22 from the June 2017 higher tier paper 1. So let's see what the question is asking us. So we're given a diagram of a hexagon and we're told that the hexagon is made up of congruent parallelograms. Now congruent just means that they're exactly the same. And where AB is equal to BC, which is equal to X centimeters. So we can label that straight away, can't we? X centimeters on both sides there. Now P is the point on AF and Q is the point on CD, such that BP is equal to BQ, which is equal to 10 centimeters. Now, just so our diagram doesn't get too complicated, we're not going to put that on our diagram just yet. Now, we're given an angle. So we're given the angle ABC, which is equal to 30 degrees. Now, we need to prove that cos of the angle BPQ is equal to some expression that's been written here. So quite a lot of information to deal with all at once. But one thing that we need to think about is, what sort of methods can we use to actually get this expression? So the first thing that comes to my mind is, when it comes to this question, there's two triangles we can form, can't we? So we've got this green triangle that I'll outline here, but then we've also got this sort of pink triangle here that we can also deal with. So in other words, we're dealing with two triangles here, aren't we? But how does that help us get to the answer? And the main reason why is, if we think about what we need. So if cos of PBQ is here, or the angle PBQ, apologies, is there. Finding cos of it, what is the rule or the equation we know that involves cos and it involves triangles? It's the cosine rule, isn't it? So the cosine rule. Now, what was the cosine rule? The cosine rule was c squared is equal to a squared plus b squared minus 2ab cos c, right? Now, in this case, our angle C is going to be the angle PBQ. But then when it comes to our triangle, what are A, B, and C going to be? Now, in this case, A is going to be the side PB, B is going to be the side BQ, and then C is going to be the side PQ. So let's just substitute all of those into our cosine rule and see what we get. So C is going to be PQ squared, then A is going to be PB squared, B is going to be BQ squared, then we have minus 2 lots of PB, BQ, cos of PBQ. Now here, if we look back at the question, we're given what BP is, we're given what BQ is. So in other words, we have PB, we have BQ. Now, do we have Q or do we have PQ? PQ is a side that we don't have. So the only thing that is stopping us from finding an expression of cos of PBQ is the fact that we don't know what the length of PQ is. So in other words, the main step that we need to realize to answer this question is we need to find the length PQ. So let's go ahead and try and do that. So how do we do that? So first, or now, let's shift our focus to our green triangle. So let's rub out this pink triangle for the time being, and we'll go back to that in a second. Now, with our green triangle, how could we go about finding PQ? Now, something that we should realize is, since the parallelograms are congruent, they're exactly the same, aren't they? So, in other words, AC is exactly the same in length as PQ. So, in this case, let's find out what AC is, and once we've found out AC, we've automatically found out PQ. So, the questions told us that the angle ABC is 30 degrees, and we've also been told expressions for the sides opposite, or next to the angle. Now from here, since we have a side angle side sandwich, we can use the cosine rule. So in that case, c squared is equal to a squared plus b squared minus 2ab cos c. Now in this case, c is going to be ac squared. Then a squared is just going to be x all squared. B squared is just going to be x again all squared. Then we have minus 2 lots of x times by cos of 30. Now, the next thing that we need to think about is, what is cos of 30? So there's different ways you can memorize or learn your trig values, but cos of 30 is one of those values that you need to just know. So feel free to use a table, feel free to use, there's certain triangle memory tricks you can use to also remember these trig values. But in this case, cos of 30 is root 3 over 2. So let's write that down. So then we have ac squared is equal to, now we have 2 lots of x squared, so we can write 2x squared minus 2 times x is the same as 2x squared, but then cos of 30 is root 3 over 2. Now in this case, this 2 and this 2 cancels out, so then we have ac squared is equal to 2x squared minus root 3x squared. So from here, the next thing that we can think about is, sure, we've got ac squared, but how do we get ac on its own? Or is that even something we need to do? So before we go ahead and think about that, let's see if we can write this in a nicer way. So ac squared is equal to, now there's a common factor of x squared, isn't there? So let's take x squared out, then we're left on the inside with 2 minus root 3. Now here, we should already see the similarities with our answer here. We've got a 2 minus root 3 and an x squared. So that should show us that we're along the right lines here. Now, from here, you might be thinking, okay, let's find out what AC is, so then we can find out what PQ is. But here we want to try our best to not only save time, but keep things as easy as possible for ourselves. Do we need to find AC, or can we just leave it as AC squared? Now, if we go back up to the cosine rule we did earlier here, what we can see is we don't need PQ, we need PQ squared. And another thing that we should realize is AC squared is exactly the same as PQ squared. So in other words, we found out what we need to find. Now all we need to do is sub it in to our cosine rule up here. So PQ squared is the same as AC squared, which we can write down as x squared 2 minus root 3. And that is equal to, now, what was PB squared? PB squared was 10 all squared. BQ squared was 10 all squared again. Then we have minus 2 lots of PB, which is 10, BQ, which is 10. Then we have cos of PBQ. Now, before we make cos of PBQ the subject, let's just try and simplify this out. So we have x squared brackets 2 minus root 3. All of that is equal to 100 plus 100. Now here we have minus 2 times 10 times 10, which is minus 200, cos of PBQ. Now from here, let's simplify again. So we have x squared 2 minus root 3, and all of that is equal to 200 minus 200 cos PBQ. Now here, the next thing that we need to think about is we want to get this minus 200 cos PBQ on its own. Apologies. So in that case, how about we move this 200 to the left? So in that case, what's the opposite of adding 200, taking away 200? So we have x squared 2 minus root 3, take away 200, and that is all equal to minus 200 lots of cos PBQ. But we don't want minus 200 lots of cos PBQ, we want cos PBQ on its own. So what we need to do the opposite of multiplying, we need to divide by negative 200. So in that case, what does that leave us with? So we have x squared 2 minus root 3, and that is being divided by negative 200. Then we have minus 200, which is being divided by itself, so we have plus 1. Then that is equal to cos PBQ. Now, all that's left is to look back at our answer and see if we have it. Now, here we can slightly rearrange the way that we've written our answer, so we can instead write it as 1 minus 2 minus root 3 x squared over 200. And that is exactly what the question has wanted us to prove. So in that case, that would be question 22 for paper 1, June 2017, all done. So the best advice I can give when it comes to questions such as this is to look at the information given and try and figure out a method to getting to the answer. So here the trick was to use 2 different triangles to get all the information we need. And the only way you could realize that is by figuring out AC is the same as PQ. So hopefully that answers some questions you guys had. Feel free to drop any questions you have in the comments. And with that, that'll be it for today's video. Please like, comment, and subscribe. See you.